During the last years, we had many publications with our partners in industry on what they do with our inverter test system like this one. So, for example, we had one partner who is using front loading with this inverter test bed system to perform his tests and to improve development time. So, Horst, have you also read all these articles?
No, sorry.
Why not? They are interesting.
But I'm not so into reading. I want to hear and...
You want to hear?
See something. Maybe I think we need to show the high fidelity of our power amplifiers.
Let's go to the drawing board and see what we can do.
Perfect.
Okay, so how does our test system look like? First of all, we have a voltage measurement. This measured voltage is then delivered to our signal processing. And in the signal processing, there is a motor model which calculates the high fidelity performance of our emulator. These signals are then transmitted to our power units. And on these power units, we have the inverter attached, which we want to test. So what do you suggest, Horst?
I suggest, first of all, to remove that thing and add a Bluetooth receiver here. Then I think we need to process the signal, maybe some high and low pass filtering. So we remove the normal E-Motor model, and in the next step the audio signal will be processed in the power amplifier. At the end we have no inverter, we have some cool loudspeakers there, and I think a small one and a big one.
Okay, and that's
because we want to hear the bass.
Right, bass is important. So let's do that.
Let's do that.
Okay.
Okay, so first we have to remove the inverter that we have been testing before. Now we want to attach our loudspeakers to the UV and W phase, where we use UV for the satellites and the VW path for the subwoofer.
So this is our Bluetooth receiver. It's a prototype.
Okay, we attach the power to the board and the signal to the FPGA. The phone is coupled via Bluetooth to the EMM music player. In the upper graph, we see the current that is demanded by the loudspeakers. In red, we see the satellites, which have quite the same shape like the voltage does. And in green, we see the subwoofer trace. In this case, it is inverted because the measurement was at the other pole.
So we did it, Horst. Why did we do it?
Because we can.
You're right. So we have seen that our high-performance, high-fidelity emulator is also capable of producing very clear sounds using these loudspeakers, which is a huge benefit if you also want to emulate motors correctly with all their harmonics and so on.